Good morning, everyone. I hope everyone is well and happy this morning. We're going to spend a little bit more time this morning with trig and with sine, cosine, and tangent. Okay, I hope everyone can join me, who needs to, can join me with our video conference later on this morning to ask homework questions. We did a lot last time with unit circle and with angle and with radian angles and degree angles and so on. So that's super important that you understand that bit about how the unit circle works and about how radians and degrees work on the unit circle and about how the sine and the cosine and the tangent functions are defined. Everything that follows from trig basically rests on that foundation. Okay, now, so we're going to go a little bit further today, and we're going to extend our knowledge of angles to angles larger than 360 and angles smaller than 0, or in terms of radians, larger than 2 pi radians or smaller than 0 radians. Okay, and then we're also going to define a concept called reference angles, which is useful for those angles outside of the first rotation 0 to 360 degrees. Okay. First off, a little bit of notation, or rather, vocabulary here. Remember, we're talking about this unit circle here, which is a circle of radius 1. Where the coordinates of the circle we're going to give by A and B. So if this is the XY plane and that's the origin, right? Then we know that, then if A comma B are coordinates on the circle that have got an angle theta with this initial side, which is always the ray heading out to the right, right? This is a 0 angle here. Theta is measured counterclockwise around the circle, or we could have negative angles measured clockwise around the circle, right? The unit circle and the way the sine and the cosine and the tangent functions work is that each coordinate A or B on that circle is associated with an angle. So this angle theta is associated with one single point, A comma B, right, where A is the x coordinate of the circle and B is the y coordinate, and the sine theta was equal to B. That's the second one. Cosine theta was equal to A, and then tan theta was equal to the ratio of the two, B over A, which corresponds to sine over cosine, or opposite over adjacent. Okay? So that's kind of how this works. Now, typically, this is how the functions are written out, right? Where theta, the angle, is the input of the function, and the function and the circle, the unit circle value, the A, the B, or the B over A, are the output, what we'd call the y. This is why we don't want to get confused about what's x and what's y. In terms of the sine and the cosine and the tangent function, the angle is the input, and the x, quote unquote, and the A or the B or the B over A, that would be the output, what we would call the y. So this is why in trig function format, they're written out like this, right? Okay, so kind of like this. So for cosine, it would be theta A. For sine, it would be theta B. And for tangent, it's theta B over A. Those are the ordered pairs that make up the function. Okay? Now, I don't know if we're going to have time to graph these functions and get sine curves and cosine curves and tangent curves, but we'll see. That may be more of a pre-calc topic. We'll see. Maybe next time. If not next time, then we won't do it, because next time's our last time. Okay, anyway, so that's how the ordered pairs will work. That's why I wanted to use A and B for our unit circle here, because they aren't really x and y in a function. Those are the functions that generate the x's and the y's. Anyway, all right, so down here, the next part I want to show you is that this, on every angle, that's the initial side of the angle, And this side up here that makes the other side, the vertex of the angle is always at the origin there at 0, 0, right? And this is going to be called, and it sounds pretty ominous, but that's called the terminal side. The side in the unit circle that rotates around in effect and completes the angle from 0 over here, that's called the terminal side. Okay, so every angle has a terminal side, and it's somewhere in the circle. Also, notice that the circle is made up of 4 quadrants, and the quadrants are numbered like this. This is and this is when let's spell that out, quadrant, right? Quadrant for fourths. It divides, the circle is divided into four regions, 1, 2, 3, 4, and they're numbered like this. This is the first quadrant, or Q1. This is the second quadrant, or Q2. This is the third quadrant, or Q3. And this is the fourth quadrant, or Q4. It's numbered clockwise, or rather, counterclockwise in the same direction that we measure the angles. Okay? All right, so now Q1, all the angles from 0 to 90, or if you're in radians, 0 to pi over 2, those are angles over there. Those are said to be Q1, or quadrant 1 angles, right? So any angle like 85 or 62 or 31 that is less between 0 and 90, that's said to be a quadrant 1 or a Q1 angle. If your angle measure is between 90 and 180, say 150 or 137 or something, you're said to be a quadrant 2 or a Q2 angle. Okay, if your angle measure is between, and by the way, for radians, that's between pi over 2 and 3 pi over 2. Okay, and then Q3, that's down here. So this is I guess I'll draw it out here, I suppose. So that would be a Q2 angle right there, because the terminal side falls into the second quadrant after starting over here. Here is a Q3 angle, say, because its terminal side falls in this Q3 region after starting over here, and it's measured all the way over here, all the way from 0. So this angle measure here, this would be somewhere between 180 and 270, or that's supposed to be pi and 3 pi over 2, and the Q4 angle, use a different color, and the Q4 angle, purple, that's going to be this one over here somewhere, right, where it's the terminal side is in the fourth region down here. That's called Q4. Use Roman numerals to number them. Okay, and that's an angle that's going to be between 270 and 360, or between 3 pi over 2 and 2 pi if you're measuring in radians. So if the problem says, what quadrant is it in, you're going to be able to tell by looking at what region it's in, right? So for instance, if you are 120 degrees, right now ask yourself, what quadrant are you in? I'll stop for a minute to give you to think about that. So what quadrant is 120 in? If you said Q2, you're right, because 120 is between 90 and 180, right? Okay, so what quadrant would 312 degrees be in? So that's Q2 is what we would write there. Okay? What about 312? Well, that's going to be in, that's 312 is between 270 and 360, so that would be somewhere in Q4. And we would simply just write Q4 like that. If we said, how about 190? Well, 190 is between 180 and 270, so that would have to be Q3, and we'd label it like that, right? So we're going to have some questions where you're going to be given some angle measures, and you're going to be deciding, what quadrant is it in? Okay, now what if it's negative? Well, negative requires a little bit of visualization maybe, but what about negative 135? Well, you've got to visualize that if I'm negative means we're measuring this way. And positive 135 would be around over here in Q2. So negative 135 would wind 135 degrees backwards, and you can see that actually negative 135 is going to be in Q3. Okay? What about negative 45? Negative 45, positive 45 would be 45 up, negative 45 would be 45 down, so negative 45 is in Q4. So in terms for negative angles, in terms of quadrants, you've got to think about the quadrants as coming in reverse order. Okay, and then anything over here, so if it was negative 210, right, where would that be? Well, that would be net positive 210 would be 180 plus another 30, so it'd be in Q3. Negative 210 would be 180 backwards plus another 30 up, so negative 210 would be up there, right? So that's going to be, so negative 210 would be in Q2. Okay, very good. So that's kind of how that goes with the quadrants, all right? So put that aside here. Now what about angles bigger than 360 or less than 0, right? Well, okay, we just have to figure out, you know, you remember that this unit circle actually sort of constitutes a weird kind of number line. So if we start here and measure our terminal side, all the way, rotating all the way around like that, well, it could just keep rotating and get angles more than 360. Okay? So what about an angle of 870? So what quadrant would angle 870 be in? Well, you've got to think that, okay, 870, that means we're going to start here at 0, and we're going to keep rotating around until we've counted up to 870. So I would rotate around. That's 360. Oop, not there yet. We'd keep going, right? And we'd rotate again. Ooh, that's 720. Still not there. So we'd rotate all the way up to, keep going till we get to 870, right? So, and that's, we haven't gone, it was from 720 up to 800, from 720 up to 870 is less than a 360 degree rotation. So that means that it lies somewhere in that rotation. So here's how we'll figure that out. I'm going to take on Mr. Calculator here, or you can do it in your head if you want to. Okay, I'm going to divide 870 by 360. And that is, as you can see, about 2.4. So that's going to rotate. So that means that it's 2 rotations plus a little bit more, right? So now that I know that, so if it's 2 rotations, that means it's going to rotate, like I said before, once, twice. So that 2 rotations is 720 degrees. So this is, so I'm going to write this out here. 870 divided by 360 is about 2.4, right? So that means it makes 2 rotations plus a little bit more. That a little bit more, that'll tell us what the actual, you know, the angle, that'll tell us what quadrant it's going to be and what angle it corresponds to, okay, within the first rotation. So 2 rotations, that's 720 degrees. So I'm going to subtract 870 minus 720. 870 minus 720, and that is equal to 150. So that means that the 870 degree angle, what that corresponds to, in fact, is 1 rotation, 2 rotations, and then all the way over here to the 150 degree position, right? So they're not the same angle, 870 degrees is its own angle. But the point is that 870 and 150 reside in the same point on the unit circle. And so, for example, would have the same sine, cosine, and tangent. And also that tells us 870, by the way, for immediate purpose, oh look, that's a Q2 angle, because 150 falls between 90 and 180. Okay? So how about this one? How about number 2? How about another one here? Number 2. How about 1450 degrees? What am I going to do? I'm going to divide that by 360. So 1450 divided by 360, right? 1450 divided by 360, that's equal to 4.027, where the 7 repeats. Okay, that means it rotates 4 times. We're starting here, we're going to go around once, twice, 3 times, 4 times, plus then a little bit more to get to where 1450 would be, right? So now I'm going to multiply, I'm going to get a different color here. Oopsie. 360 times 4, that's 1440. So 1450 minus 1440. What I'm doing is I'm subtracting off all those 4 excess rotations. Okay, 1440 is equal to 10, right? So what this 1450 degree angle is, it's rotating once, twice, 3 times, 4 times, and then 10 more. So I guess that would be 1450 would be approximately right there, right? Right at the 10 degree position. And that would occupy 1450 is its own angle, right? But on the unit circle, it occupies the same position as the 10 degree angle. And that means, so the sine, the cosine, and the tangent would be the same because it's in the same point. And we're going to say, oh, 1450, that's a Q1 angle because as you see, the angle fell into the Q1 region, right? Okay, good. Now let's try a negative one here. How about negative 1160, right? That's starting here, you understand, 1160 degrees around, where each rotation backwards would be, negative 360. So I'm going to divide, still going to divide it by 360, because we're still counting up how many excess rotations that is. So that's negative, so that's 1160 divided by 360, right? And that is negative 3.2. So that means 2 bar. That means it's going backwards 3 rotations plus a little bit more in the backwards direction. So that's 3 times 360, 3 times 360. That's, in fact, so 3 times negative 360 is negative 180. So I'm going to subtract from 1160 minus 1080, and that's negative, so yeah, negative 1160 minus negative 1080, that's equal to negative 80. So that's 80 degrees backwards, you understand. That's down here in Q4. So negative 360 is a Q4 angle. Okay? So that's how that works. We'll do another negative one here, and then I'm going to end this video, and the next one will be about reference angles. Okay? All right. So there's that. We'll do one more example here. Okay, this is going to be example 4. What if we've got an angle of negative negative 10,123 degrees? That means we're going to start here and go around 10,000 times, right? That's all right. We just have to find out how many excess rotations there are. So I'm going to do, negative, on Mr. Calculator here, negative 10,123. I'm going to divide it by 360, right? And that tells us, oh, look, that's negative, hopefully you can see that, negative 28.119. So that's approximately, that's 10,123 divided by 360. That's negative 28.119, right? 4 bar, the 4 repeats apparently. So that means that on the unit circle here, here's a little tiny unit circle. We're going to start here and go around backwards because it's negative 28 times, and then a little bit more, right? However much of the, so this is going to give us the excess here. So I'm going to multiply, so negative 10,123, I'm going to multiply 360 times 28. So negative 360 times 28, that's 1080, like that. So I'm going to subtract. So you understand what I'm doing is I'm subtracting those 28 rotations off, which are a total of 10,080 degrees. And then whatever's left over, that's going to tell us what quadrant the angle's in, okay? And so I'm getting negative 43, right? Oop. Well, negative 43 is down. That's less than negative 90. So again, that works out to be a Q4 angle. And it's equivalent to negative 43. It's got the same position on the unit circle. Okay, are we okay with that? Hopefully, okay. So we're what is this? 22 minutes in. So I'm going to stop here, and we're going to go ahead, and I'm going to do the next one will be about reference angles. Toodaloo.